So yeah, my name is Bryan Hughes. I go by Nebrius on Twitter, GitHub, and basically everywhere else. And I am a developer evangelist here at Microsoft. So welcome to my office, everyone. So this one I'm going to talk about building a JavaScript-powered aquarium. So I have this aquarium at home. I've had it for quite a while. And before this aquarium, I had another one that was very, very similar. And it's a great aquarium. You can see my fish in there. They're super happy. So in this aquarium, it has a day and nighttime lighting system. It has basically like really bright white LEDs for daytime and like dim blue LEDs for nighttime, which is awesome. The fish love it and things like that. But there is one problem with it, and it's that to control it, we have these capacitive buttons right here. And so it works, of course. It works totally fine. But the problem is, in order to change the lighting, I have to get up and physically press a button. This sucks because, well, first of all, I'm not a morning person. I don't want to get up in the morning and turn lights on. But also, I'm an evangelist. I travel pretty frequently. I'm not always there to do this. This is something we want to automate. Historically, like in the days of fluorescent LEDs, it was just on-off an electrical outlet. So you put like an electrical timer on it, works fine. Can't do that with this, though, because how do you switch between the lights? So I was like, I got to automate this. I got to fix this in some ways. And so I did exactly that with the Raspberry Pi. Now, this is actually a pretty old project. I first started working on this project, as you can see from my first commit, way back in 2013. This is one of my oldest open source projects I've ever worked on. And this actually opened up a lot of doors for me, in fact. I started working on this before I even knew that NodeBots was a thing. But I wrote this in JavaScript. And that actually led me to becoming a contributor on the Johnny-Five project, which is a robotics framework for Node.js if you're not familiar with it. I maintain the Raspberry Pi support for that project. And so this went along well. It was doing pretty well. But then, like I said, I wrote Raspberry Pi support for Johnny-Five. So about 2 years later, I rewrote a good chunk of the project to use that. And it's going along. It's doing pretty well. But it starts falling behind. There's some parts that stopped working after a while. It was running Node 0.10 in 2017, which is not a good thing. So I was like, all right, I got to just rewrite this entire thing. And also, I work at Microsoft, so I had free access to Azure, and we got a bunch of IoT stuff. So I was like, I want to play with all these toys that I have now at my disposal. And so I did just that and rewrote the entire thing to make it connected to the cloud. And so the new system has this basic system architecture to it. There are more or less 3 separate components. There is the controller, which is the Raspberry Pi itself. Then there's the server, which is a collection of various pieces doing things in the cloud. And then there's the client, a web browser. I wanted to set this up so that I could actually control and configure my aquarium from anywhere using the web. And so it's divided into these 3 sections, and it's actually running in production. And so first, I'm going to show you kind of what this looks like in the end. Here we can see the aquarium once again. I have a tablet sitting in front of it, actually this tablet right here. And it's set up so that it controls the lighting based on a schedule, but then you can also put it into override mode and change what the lights are doing, which I'm going to do exactly here. So I go and I put it in override mode. I go from the daytime lights to the nighttime lights. You can see the blue. And then I turn the nighttime lights off entirely. And then I have it go back into program mode. So that's pretty cool. And then another thing it also does is it monitors temperature, and it stores temperature data, does analysis and alerts and stuff like that. All right, so the way I implemented this, we'll start by talking about the controller. This right here is a photo of the actual Raspberry Pi hardware setup along with a couple of other things. At the bottom left, that big green board, that's a Raspberry Pi 3 Model B. That is the newest, most powerful version of the Raspberry Pi. And connected to that are 2 separate peripherals. The other big green blocks with the white squares, that is what's called a relay module. And so what a relay does is it takes a really low power signal, and it will turn on basically a switch. You can think of it like a light switch, except instead of using our fingers to turn it on and off, it'll actually use an electrical 1 or 0 to turn it off. So you can control it from programming. And this is really great because those LEDs are actually really high power. They're a high voltage, high current. You can't connect it straight to a Raspberry Pi because it'll actually fry the Raspberry Pi. So you put this device in the middle, and that allows this low-powered device to control this really high-powered light. And then the other thing is, it's kind of hard to see, but there's a red, white, and black cable. It turns into a red and yellow cable in the upper left corner. That's the cable for the temperature probe. And that kind of goes off into the tank. And I also have a fan to keep it cool just because it's a Raspberry Pi in an enclosed structure, and they need some cooling. You don't want to have no airflow. So that's the hardware. And then the software, so inside the Raspberry Pi is basically an onboard computer. It's a computer in the size of a credit card. So it runs Linux, and on top of that, I'm running Node.js. And so inside of Node.js, I use two key libraries to do everything with. One is Raspi JS, which is the library I wrote that Johnny-Five uses to get Raspberry Pi support. And the other is one called IoT Hub, which I use for communicating between the Raspberry Pi and the cloud, which I'll talk about that more in just a minute. And then so on the Raspberry Pi, it starts up every single morning at like 0 o'clock, midnight. It will basically load up the configuration and then program out the schedule for the day. You'll figure out what is the sunrise time for today? What is the sunset time for today? Because as we know, that changes throughout the year. Like we don't have much sunlight right now. And it just schedules that out. It sets like some timeouts and stuff, so then it'll actually change the lights. And then everything's written in TypeScript because I just really like TypeScript a lot. All right, so next up on the server is broken down into 4 separate pieces. I'm using Azure SQL, which is it's a Microsoft SQL instance, but it's in Azure provided, the way databases are provided in the cloud. It's all managed for me, stuff like that. And then I also have a Node.js app there that does a variety of things I'll talk about in a minute. And then there's 2 other services I use in Azure. One is IoT Hub, which I just mentioned, and another one called Stream Analytics. So IoT Hub is a pretty cool kind of suite that we have. It provides a whole bunch of stuff geared specifically towards IoT. Specifically, it handles device management and provisioning. Whenever you have an IoT device, usually the first thing, and you want to connect to the cloud, you have to provision it. Because if you think about an IoT device, you don't have a user interface. You can't put in a username and password. So but you still have to handle authentication. You want to know the device that you're talking to. You want to know which device it is and what it's authorized to access. And so we do that using a mechanism called provisioning in just a general sense. And so this Azure IoT Hub handles a lot of that stuff for us. And also handles authentication with messaging and things like that. Just making sure throughout every single step of communication that Azure knows exactly which device it's talking to, and that is indeed authorized to talk to that device. And then finally, like I said, it provides messaging itself. And that messaging can be built on top of a couple of different protocols depending on what you want, what kind of communicating you want to do. It can use MQTT, AMPQ, or HTTPS. Each of them has pros and cons, and kind of read at the docs, figure out what you want, and pick one. And then for all of this, Microsoft provides some Node.js libraries that makes it really easy to consume and use. If you want to see the code, I can definitely show you that later. So that's IoT Hub. And I also mentioned Stream Analytics. So the device talks to IoT Hub directly, and then IoT Hub talks to Stream Analytics. So Stream Analytics is a runtime event processing pipeline. There's a whole bunch of variants out there. This happens to be ours. It's pretty cool. So it's a way of doing event processing, so like very high volume event processing, tons and tons of data streaming into your server, and you want to like route it around and maybe do some analysis, stuff like that on it. And this is a runtime-less processing pipeline, so you don't spin up VMs or anything like that. And it uses a simple SQL-like language. So the idea is that you don't even really have to write very much code at all. And with this, we can glue together pretty much any other Azure service. So that little code there that like select stuff into from, that is all of the code that I wrote to take data from IoT Hub, which was just a message call on the Raspberry Pi, and pump it straight into Azure SQL. So I didn't have to write any Node.js or .NET, Python, anything like that to get data from a Raspberry Pi into a database. And I think that's really cool.
Does this SQL query results in the real time, as in when the data is streaming, it gives the data of that particular time? Is that what you're saying?
Yes, yeah, this is completely real time. So like the latency from whenever the Raspberry Pi posts that message to the time it's in the database is like milliseconds.
Okay.
And in fact, one of the things we see, there's a graph right there that actually shows the number of events coming in. I only have one device, so there's really not much activity on it, but you can see every 5 minutes it was pinging. When I took the screenshot, I was actually doing some maintenance on it and like restarting the app a bunch, so that's kind of what that weird stuff is in there. But yeah, it's a really cool system that makes it super easy to do this stuff. Like I had this whole pipeline of going from the Raspberry Pi to SQL like up and running in like 5 minutes kind of thing. But then I do still have a Node.js app running in the server, and it does like a lot of other stuff. That sort of thing we saw up in the corner. So this runs inside of an Azure Web App Service, which is the name that we have for our platform as a service setup. So basically we're saying, like, I want to run a Node app. I don't really care about managing a VM myself or having to deal with like updates or updating Node and all that kind of good stuff. And so with Web App Services, it just does that all for you. Of course, AWS has the same equivalents in there. And so this server does a variety of different things. The main thing it does is it provides support for the web app, for the browser app itself that we use to control it. So it serves up those static files, as well as doing a little bit of templating. And then it also has a couple of endpoints defined for this app to kind of go and fetch all kinds of data, which we'll see what the client looks like here in a minute. And it does a couple other things too. It does some meta-analysis on this temperature data. So we have this data that's coming in. It's like every 5 minutes, it's basically saying, here's my lighting state, here's my temperature. But that's a lot of data, and it becomes very stale very quickly. We don't really need it. So like once stuff gets to be about a day old, this server will then go in and just sort of like crunch it all down and get like a high and low for the day. And then once the data is a month old, it kicks it out entirely. And then also it sends the lighting configuration back to Azure IoT Hub. There's some ways that you can actually, that IoT Hub makes it so you can configure a device really easily. They have this concept of what they call device twins. I could talk about a lot more later. But it's basically a configuration for your device that's super easy to pass around without having to write a lot of manual code to do it. And so this Node server app is the one who actually sends the configuration back to the device. And that configuration is things like, run in override mode, or set the lights to this, define this schedule, stuff like that. So I use Express and Pug for my templating on this. And once again, it's written in TypeScript because I just really, really like TypeScript a lot. And so finally, we have the client, which is a web app. It runs in the browser, obviously. And so what this does a couple of different things. So it displays what the current state of the system is, or well, the last reported state. So it might be up to about 5 minutes old or so. But it displays what's the current temperature in the tank, what's the current lighting. It'll show like the next state that's going to change, stuff like that. And also, I can like adjust the schedule if I want, and various things like that. So to handle authentication, because I don't want just anyone to log in and start messing around with my aquarium, that would not be fun. My fish would hate me. I use Facebook to handle authentication. And then every single, which by the way, I'm actually not using JSON Web Tokens at all. It's just regular session data and cookies. Yeah, and so once again, Facebook's great. It's off the shelf. I can get access to anyone I need to, because basically everyone has a Facebook account. And then this was written using all the kind of typical stuff. I wrote it using React, Redux. I used Chart.js to show some graphs. And then TypeScript, because I love TypeScript once again. And I use Webpack to build everything all together. All right, so I'll show you what that software looks like. Which, all right, I switched laptops, so I'm going to have to load this up. Hopefully, I'm still logged into Facebook, because that takes a little while. Oh, perfect, it's right here. Let me reload that. OK, good. All right, so this is what the web app looks like. So the upper left corner, that's just the name of the currently logged in person, which is me right now. On the right, that's actually the name of the device itself that is connected to. So hypothetically, this could support controlling multiple aquariums and multiple users. I haven't tested that because I only have one aquarium, but that support should be there. We can see the current state. We can see my aquarium is currently in program mode. Program mode means it's running on that schedule that was predefined at the beginning of the day. It's currently in nighttime mode, which, looking outside, that makes sense. That's good. I've been worried if it said something else. Also, it tells me what time the Raspberry Pi thinks it is. This can be useful, I suppose, just in case the clock gets really off. It also tells me about the next transition. So it says the next time that this is going to transition is going to be at midnight, at 12 a.m. PST. And it's going to go from nighttime mode, which is those blue LEDs, to completely off mode, which is exactly what I would expect. And then finally, it says the current temperature is 25.25 degrees Celsius, which is pretty typical. We can see the temperature for the day, over the entire day. There's this little dip right here. I was taking some photos as we saw earlier. I actually accidentally yanked the thermometer out of the tank without realizing it. So it sat there for about half an hour. So that's actually the air temperature of the room around me. That's that little dip there. But I actually captured it, which is cool. And we can see the monthly temperature. So we can see the temperature in the tank has actually fluctuated a little bit. It has a heater in it with a regulator, so you'd expect it to be perfectly smooth. But it shows that it's not a perfect heater and things like that. You can see that really cold snap around Christmas, actually, which is kind of cool. And then finally, we go down here, and we can see the schedule. So the first thing it's going to do, that first entry there, is at sunrise, it's going to set the lights to day mode. The type dynamic or manual, that means do we want to base this on a solar event, sunrise, sunset, or do you want to just have it occur at an exact time? And so for this one, we're saying dynamic, sunrise. The second one is sunset. Same thing, we'll set the lights to night mode, dynamic, sunset. And then the last one, this is the one where it says it's going to turn off at midnight. You can see I actually have a daylight savings time bug in it. It said the next transition is going to happen at midnight, but I entered it as 11. Oh well, that happens. Time zones are a difficult thing. But anyway, so this is it. And then if we wanted to, we can go through and we can move things around. We can add new entries. We can delete them. And notice I'm not hitting the apply button because I don't want to change the lights on my fish right now. They would not be happy with that. And then we can also go into override mode and set anything we want. So this is actually really useful in Aquarium. Sometimes late at night, maybe something's going on and I need to check it out and turn the lights on. And so, yeah, that's kind of what this web app looks like. And with that, I can do all kinds of stuff. And you notice that this is going through a website, aquariumcontrol.azurewebsites.net. That's the default domain that Azure gives you. I could do custom domains, stuff like that. But it means I can access this anywhere in the world. And I can kind of see what's going on with my aquarium. And some other things, like I have a bunch of new features I want to implement that I haven't done yet. One thing Stream Analytics gives you the ability to do is to define alerts. So like if a certain value goes outside of a certain range, you can send out an email, text message, stuff like that. That's all baked into Stream Analytics. And so they'll make sense for this. So if the temperature gets too high or too low, I could have it text me saying hey, something's going on. You should probably go check this out because this could hurt your fish. Haven't had a chance to do that yet, but it shouldn't take too long to do. And I think it's really cool that I can do all this kind of stuff for a simple aquarium. And so going back here, we can see you can go check out all the source code here. It's all GPL licensed, open source, stuff like that. And it's not particularly big. I would say I did the bulk of the work in about 2 or 3 weeks. And then just little bits here and there to polish it up after that. So using a lot of pre-built off-the-shelf stuff made this a pretty quick project, even though it's doing a lot of really custom stuff. And so yeah, with that, I want to thank you all for listening and questions. So the question, how do I feed fish when I'm away from home? That's not in this system yet. I use a standalone. But that's actually another thing I really do want to get integrated into this. So I have, it's already electronic. It has a motor that basically spins once a day, and it tips this tumbler over. And so I just got to dig that open, crack it open a little bit, figure out basically where the wires are to control the motor. And once I can find out where that is, just cut the rest of the pieces out, and I can wire that up to the Raspberry Pi and have it control it instead. And so same kind of thing, just like controlling the lighting, I could actually probably even reuse a lot of that same code, since it's setting up a schedule and having a thing, mechanical thing happen on the schedule.
A couple questions. So you said there's a service that tells you what the sunrise and sunset is. What's that?
What am I using to determine sunrise and sunset? There was a time I queried a service on the internet many, many years ago, but I stopped doing that because it turns out you can calculate the sunrise and sunset time just using a series of formulas. You give it a latitude and longitude, and you can go from there. So I am using an NPM package. It's called SunCalc, SUNCALC, and it does all that for you. But it's actually an offline module. It doesn't have to query a service.
I missed the brand of your opto isolators. Are they available on the web?
That's a good question. So the story on where I got my, they're actually solid state relays, not opto, well, they might have an opto isolator in them. Actually, I'm curious now. Anyways, so the solid state relays that I used, where did I get those from? You can find those on the internet a lot. I actually bought those from a Radio Shack as it's going out of business, so you probably can't buy it anymore. But there are equivalents out there.
Yeah. Regarding the stream analytics which you're talking, I mean, you're running SQL queries on a data stream. Does it pass the data into some time series, like chunk the data and then fires the SQL query, or like it's independent of time?
So the question then is with the stream analytics query, which is right here. When does that fire? Does it like batch up a bunch of data going in and then run it on that batch? No, it actually runs it on a per event basis coming in. And also, I do want to clarify, it's an SQL-like language, but it's not actually SQL. So like a couple of things, we can look at this a little more in depth. When it says select, those are actually fields out of the keys out of a JSON payload. And saying like, take out these things from this payload. That from thing is saying what Azure service are we going to pair into it. So that's obviously not SQL, that's specific to Azure. And then into is where we're going to put it. So I'm saying take this from IoT Hub and put it into Azure SQL. But it could come from others. There's I forget exactly how many, but there's maybe a dozen different event sources and maybe another dozen different outputs. So we could pass into a different database system. Like we have one called Cosmos DB. That's a wrapper around basically your database of choice. So if you want to use MongoDB or something, you could do that. You could also pass it into file storage. You could pass it to other event systems. You can have multiple stream analytics that are like piped together and kind of whatever else you want.
Yeah, it's totally different stream.
Yeah.
Have you thought about doing a camera?
Have I thought about adding a camera? Yes. This is another one of my stretch goals that I just haven't gotten around to. So a story, a couple years ago I went to Berlin to speak at a conference, and my partner went with me. We were going to be gone for 2 weeks. So I actually did set up a webcam to do it. So like the hardware is not all that hard to do. I just got to like tie the various bits together to get it like routed to the same system. Sorry, that was all the time we had.
Yeah, Brian will be hanging around though, so if you guys more questions. So thank you, Brian.
Thank you.